Hello everybody, welcome back to channel Best Woodworking. Cutting down a large old tree in the forest is one of the most dangerous tasks a person can undertake, especially when using a chainsaw. The immense size and weight of the tree, combined with the unpredictable elements of nature, create an environment where even the most skilled professionals must remain extremely cautious. One mistake could lead to serious injury or even death. Despite these risks, experienced loggers follow a strategic method to ensure the tree falls in the desired direction, using cuts and wedges to guide the process. The first step in cutting down a large tree is assessing the surroundings. Before making any cuts, the logger inspects the area to identify hazards like power lines, nearby buildings, or other trees that could interfere with the fall. They also observe the tree's natural lean and consider environmental factors like wind direction and speed. Once the path is clear and the conditions are right, the cutting process begins. The most important element of safely felling a tree is controlling its fall. To do this, loggers use a series of cuts to direct the tree's descent. The first cut made is the notch cut, which helps determine the direction in which the tree will fall. This cut is made on the side of the tree that faces the direction the logger wants it to land. Using a chainsaw, the logger cuts diagonally downward, creating an open wedge in the trunk. This notch should be around 1/4 of the tree's diameter and serves as the visual guide for the tree's path as it begins to fall. After completing the notch cut, the logger moves to the opposite side of the tree to make the back cut. This cut is crucial because it releases the tree from its base. The back cut is a horizontal cut made on the side opposite the notch, but it must be positioned carefully. The back cut is placed slightly above the bottom of the notch cut, leaving a strip of wood between the two cuts, known as the hinge. This hinge controls the tree's fall, allowing it to tilt in the direction of the notch. However, it's not always enough to rely on cuts alone to guide the tree's fall, especially when dealing with a large old tree. That's where wooden wedges come into play. After starting the back cut, the logger inserts one or more wedges into the cut to keep the tree from settling backward and trapping the chainsaw. These wedges are made of durable wood or plastic and are tapped into place with a hammer or axe. By lifting the tree slightly, the wedges help to tip it in the right direction, assisting in guiding the tree to fall where the logger intends. The final moments of tree felling are the most dangerous. As the back cut nears the notch, the tree will begin to lean and fall. At this point, the logger must quickly retreat to a safe location, ideally moving along a 45-degree angle away from the direction of the fall. A pre-planned escape route is critical in avoiding injury from falling branches, debris, or the tree itself. These branches, sometimes called widowmakers, can break off unpredictably and cause significant harm. Once the tree begins to fall, the logger's precision in making the notch cut, back cut, and inserting wedges will dictate how safely the tree lands. When done correctly, the tree falls in a controlled manner away from danger and in the desired direction. Once the wood is harvested, the next step is transporting it to the factory for processing. This crucial phase often requires specialized vehicles capable of handling tough terrains, especially when the logging operations are in mountainous areas. The trucks used in these settings need to be rugged, reliable, and able to navigate narrow, steep, and challenging roads. One such vehicle that is frequently employed for timber transport in these demanding environments is the Volvo wood transport truck, often paired with a semi-trailer. Volvo trucks are known for their robust build and ability to carry heavy loads over long distances. Their semi-trailers are specifically designed to transport large quantities of timber efficiently, even in rough off-road conditions. Volvo's advanced technology, such as its traction control systems, ensures that the trucks can maintain stability and grip even when traversing loose or uneven ground. These features make Volvo a reliable choice for transporting timber from remote mountainous logging sites to processing factories. In addition to Volvo, the Scania G 486x6 is another truck frequently seen in forestry operations. This all-wheel drive powerhouse is specifically designed for challenging environments like the narrow and steep turns found in mountainous areas. The Scania G 486x6 has exceptional torque and power, enabling it to handle steep ascents and descents with ease, even when fully loaded with timber. Its six-wheel drive provides enhanced traction, allowing it to maneuver through tricky spots where less capable vehicles might struggle. Scania's trucks are built with durability in mind, making them highly dependable for logging operations in difficult terrains. Another popular choice in logging is the MAN 6x6 timber transporter. This vehicle is built for off-road logging operations and is equipped with a four-wheel drive system designed to handle extreme conditions. The MAN 6x6 is often employed when the terrain is too rough for standard trucks. Its powerful engine and rugged suspension allow it to haul heavy timber loads across uneven, muddy, or rocky paths without compromising safety or efficiency. The 6x6 drive configuration gives it the capability to climb steep slopes and navigate sharp, narrow turns, common in mountainous areas. As logs are unloaded, they are prepped for the cutting process, entering the system through the log deck. The log deck plays a crucial role in organizing the logs before they're processed. It holds the raw timber and feeds it steadily into the mill, ensuring a consistent workflow and reducing manual handling. Operators control the deck to move the logs into position, maintaining the rhythm of the operation and preventing bottlenecks. This smooth transfer is essential for the seamless running of the sawmill line. Once the logs reach the cutting area, the TV6000 twin-band vertical saw comes into play. This powerful machine is central to the first breakdown of logs. It uses twin vertical bandsaws to cut large logs into manageable sections, such as cants, a partially processed log, or boards, depending on the size and type of the wood. The TV6000's vertical configuration allows it to make precise cuts while minimizing waste, improving yield from each log. A key part of this process is the slab removal system, which swiftly disposes of the slabs, those outer layers of bark and rough wood, that are cut away during the initial sawing. This system ensures that waste material is quickly cleared, preventing any obstructions in the workflow. The slabs are either processed further for byproducts like wood chips or discarded, depending on the factory's output goals. This system is a critical element in maintaining an efficient clutter-free workspace and maximizing the use of each log. After the logs have been cut and slabs removed, the semi-processed wood moves to the sorting table. This area is where the newly cut wood is inspected and categorized. Skilled operators sort the wood based on factors like quality, size, and intended use. Boards might be destined for further cutting or processing, while other sections may be sent to different parts of the factory for specific treatments or finishing. The sorting process is essential for ensuring that the wood meets quality standards and is directed to the correct production line. Throughout the process, the Wood Miser industrial sawmill line operates with a focus on precision, efficiency, and minimizing waste. Each component, from the log deck to the twin-band saw, slab removal system, and sorting table, works in harmony to process logs into usable timber. This modern approach ensures that the factory runs smoothly, maximizing output while maintaining high-quality standards. The result is a streamlined wood processing operation capable of handling large volumes with ease, turning raw logs into valuable timber products. Modern wood processing line. Wooden cable drums complete production line. Wooden cable drums are essential for transporting and storing cables and wires, particularly in industries that require heavy-duty solutions. A modern wood processing line for the production of these drums represents a harmonious blend of precision engineering, cutting-edge technology, and sustainable manufacturing practices. One such innovative line is produced by Jella Still Masin, a Serbian company known for its expertise in wood processing equipment. In this article, we will explore the intricacies of the complete wooden cable drums production line and how it efficiently transforms raw timber into highly durable and functional wooden drums. The manufacturing of wooden cable drums involves several key stages, each of which is optimized for speed, precision, and consistency. The complete production line designed by Jella Still Masin is fully automated, ensuring minimal human intervention while maximizing output. This not only enhances efficiency but also ensures consistent quality across the drums produced. The production line includes several integrated machines and systems that handle each phase of the process. The production process begins with the selection and preparation of raw timber. High-quality wood, often pine, spruce, or other durable softwoods, is chosen for its strength and ease of handling. This phase is crucial because the dimensions of the wooden pieces must be accurate to ensure the final product is both functional and sturdy. Jella Still Masin's advanced cutting machinery uses state-of-the-art saws and automated measurement systems, which guarantee that each piece of wood is cut to perfection. Once the wood pieces are cut, they proceed to the milling and shaping section of the line. Here, the wood is shaped into the specific components needed for a cable drum. The drum flanges, the large circular ends, and the drum barrel, the cylindrical center. Milling machines precisely shape the drum flanges to the required diameter and thickness, while also ensuring that the barrel is smooth and uniform. The precision of the milling process is vital to the overall performance of the wooden drums. The flanges must be strong enough to support the weight of the coiled cables, while the barrel needs to be perfectly round to allow for easy winding and unwinding of the cables. After milling and shaping, the individual components are ready for assembly. In this step, the flanges and barrel are securely fastened together. This is done using a combination of mechanical fasteners and industrial-grade adhesives, ensuring that the structure is both durable and resistant to wear and tear. The assembly process is fully automated in modern lines, like the one developed by Jella Still Machine. Robotic arms and advanced fastening systems work together to quickly and accurately assemble each drum, minimizing the risk of human error and ensuring a high level of consistency. Quality control is a critical step in the production of wooden cable drums. After assembly, each drum undergoes a thorough inspection to ensure that it meets the required standards. This includes checking the dimensions, structural integrity, and overall finish of the drum. Any defects are identified and rectified before the drum is approved for distribution. In addition to quality control, the finishing process may also involve sanding, varnishing, or painting the wooden drums, depending on the customer's requirements. This not only enhances the aesthetic appeal of the drums, but also provides a protective layer that helps prolong their lifespan, particularly in outdoor or harsh environments. Once the drums have passed quality control, they are ready for packaging and distribution. In most cases, the drums are packed in a way that ensures they remain secure during transportation, preventing damage. Efficient packaging methods also allow for optimal use of space, reducing transportation costs and environmental impact.